So moving on in our look at graphing, we start with quadratics, which we talked very specifically about how to graph vertex, roots, intercepts. We're going to move on to generic polynomials, which will be a little less specific on, and you'll kind of see why as we go along. But so before we start graphing polynomial functions, we need to make sure we know what are we looking at that's going to make it a polynomial function. So if you look at this kind of generic form, you have in front of each of these sets, you have a to, and this is just kind of a way to mark our form here to denote that we have, it says all these a's out in front, a sub n sub minus 1, a sub 1, a sub 0. These are all just the real numbers. These are the numbers out in front of our variable. And then we have x2, it says the n power to the n minus 1 power, x to, all the way down, it counts down to x to the first power. So it doesn't specify what the number has to be, just said it can't be a negative, a non-negative integer. So it has to be a positive number, no decimals, or fractions. And all our numbers have to be positive. So for instance, what you're used to seeing, something like this. f of x is, you notice these numbers, these are all real numbers out in front of the variables. And then the powers, they're all positive. The powers on the variable, they're all positive numbers, no decimals. So this is when we're talking about polynomials, we're talking about this general family of functions. So a little bit more vocab that we're going to actually use, and this is what we're going to figure out what kind of picture we're looking at, is the idea of a leading coefficient. It's going to tell us a lot of information. So far, the leading coefficient we've used, so for instance, when we did quadratics, which are a polynomial, just a specific polynomial, we use this negative sign out in front. The leading coefficient means that first number, the first number in our polynomial written in standard form. So standard form is highest power to lowest power. We've already used the leading coefficient to help us out. We know a little bit about it, and we're going to actually go into a little bit further what it's telling us. So you have this kind of official math definition, but then the leading coefficient, what is it? It's just the first number you see when you write your polynomial in standard form. So if we go back to that same polynomial we saw before, the leading coefficient is -4. So we need to know how to figure out what the leading coefficient is and what the definition on that would be, as well as, as well as the idea of a degree. Degree of polynomial has to do with the exponents. And the thing about the exponents is it's the highest exponent on a variable in all of your polynomials. So it tells you about the general shape of the polynomial. And what we'll do in degree, we've talked about degree before, but just as kind of a reminder, we kind of label our graphs here. What the degree is going to tell us is about the general shape of your polynomial. So in general, a degree 3 polynomial, and I'll sketch this, and you might want to sketch this as well. A degree 3 polynomial is going to look something like this. A degree 4 polynomial is going to look something like this. A degree 5 polynomial is going to look something like this. And a degree 6 polynomial would look something like this. Obviously with some variations as you change the equation. But the degree is going to tell you basically, the degree is the number of turns your polynomial can make as you go along the graph. So if we look at the degree 3 polynomial and you follow along with your pencil, it starts going up. If you're going from left to right, it goes up, changes directions to go back down, change directions, go up again. So the degree equals or the degree minus 1 actually is how I should write this. The degree minus 1 is the number of turns your polynomial can make. So in a degree 4 polynomial, you see it goes, you have a change of direction, change of direction, change of direction. 3 changes of direction. In a degree 5, you can have up to 4 changes of direction. In a degree 6 polynomial, you can have up to 5 changes of direction. So list below there, if the degree of your polynomial is n, so whatever number that might be, the maximum number of turns you can make is 1 less than that. Doesn't mean that's how many turns you will have. That's just the max number that could possibly be in your function or on your graph. So those two pieces of information are going to help us to decide. So we've got leading coefficient, we've got degree of the polynomial. It's actually going to help us decide about the end behavior of the graph. And so we're talking about end behavior. We're basically talking about what happens as the graph continues. So up to, and you notice this graph, the end behavior is it's going to go up and up and up and up. And then also, what happens as the graph continues on the right side, and what happens as the graph continues on the left side? What happens when these arrows go off? So when we're talking about end behavior, you're basically talking, does it go up towards infinity, or does it go down forever towards negative infinity? What happens as the graph goes off on either side? And so if we look at some actual specific examples, and so if you wanted to plug these equations into your actual graphing calculator, this is what it would spit out. What we're going to notice, and so I told you the key pieces are leading coefficient. So what we want to pay attention to, the leading coefficient and the degree. So if you look at our four examples here, and we look at the two at the top, what do you notice about the leading coefficient? Well, there's nothing in front of the first term, and these are both written in standard form, highest degree to lowest degree. There's nothing written in the front of the first terms, but so that would give us a leading coefficient of 1. In both cases, the leading coefficient is positive, and that's what we're going to be kind of paying attention to. Leading coefficient being positive, or on these bottom two examples, you have a leading coefficient that's negative. What that's going to tell us is actually what you notice in both functions. When they're both positive, the leading coefficient is going to tell you what happens on the right side of the function. So you notice when they're both positive, that means on the right side, your function's going up to positive infinity. When they're negative, what you notice is, if you graphed hundreds of functions, you'd notice this every single time. And when it's a negative leading coefficient, in this case they're both -1, the right side ends up going down. So right side down for negative leading coefficient, right side goes up for a positive coefficient. So what does the degree tell us? Well, the degree, if we're looking at the top examples here, the important thing about the degree is going to be this even or odd nature. So if on the, you notice on the left side, both examples are even numbers. On the right side, they're both odd numbers. What you notice is whatever the leading coefficient told you was happening on the right side, if it's even, it means the same behavior on the left. And we'll summarize this on the next slide. If it's an odd degree, so the degree of 3 in this case, highest coefficient is 3. Odd means it's the opposite behavior on the left side. So the degree is going to tell you what's going on the left side. The leading coefficient tells you the right side. The degree tells you what's going on the left side. So if we look at and summarize here, the leading coefficient, if it's positive, then the leading coefficient tells you the right side. If it's positive, it's going to be going up on the right side. If it's negative, your graph will be heading down. It'll be decreasing. So if you want to think about it in more math terms here, up it'll be increasing, down it'll be decreasing. The degree tells you about the left side. If it's an even number, that means it's the same as the right side. And if it's an odd degree, it's going to be opposite. So that odd and opposite matching up kind of helps to remember this. Opposite from the right side. So we've got some definite vocab here, and to get a little practice on this, just as far as the end behavior goes, because we'll get to a little bit more specifics in this later, but just for the basics, what the end behavior tells you. We have this particular graph to help us get an idea of what this is going to look like. And again, we'll get into more specifics later. We just want to give kind of a general sketch. What would our calculator show us in general? So what's important? The important information is the leading coefficient and the degree of the equation we see. So the leading coefficient, as long as it's written in standard form, the leading coefficient is going to be that number in front. It's positive. So positive tells us, the leading coefficient is telling us what's going on the right side. So the right side, if it's positive, the right side of the function is increasing. It's going up. The arrow is going to be extending to infinity, positive infinity. The degree of this function is going to tell us what's going on the left side. The degree is even. It's a degree of 6. Should have written that first. Then an even degree tells you the left side is the same. The left side is going up as well. You want to consider where your arrow is going. So we may not know what's going on the middle of this function, but for now, we've at least got to establish that on the left side it's going up and on the right side it's going up. The maximum number of turns, things like that, will help us fill in the middle part here. We'll kind of put this in the box. This is the part we need to talk about next and what we'll talk about on Wednesday.